Okay, so the first thing to do is to work on
No, this is better.
the individual components and get them
Yeah.
prepared for the assembly stage. So this is the basic Pro Mini style Arduino,
Yeah.
but it has little LEDs that waste power.
Yeah,
So there's a
yeah.
power LED there, and there's another one there, and I usually just flick the limit resistors off to disable those LEDs so they don't use power all the time. Because once your logger is assembled, those little lights are inside of a housing, so you can't see them anymore. So the first thing I do is just, there's one,
Okay.
and that's all it takes to flick them off. And there's another one, and I'm just going to flick this guy off. Oh, he didn't
A
quite.
little bit more. Yeah.
You got to wait until the solder melts. Usually, I just apply pressure, boom.
Perfect,
And when it's ready, it goes.
I actually saw that this time. Like before, it's
And
like
sometimes
I'll do it,
you get half of it off, and you have to go in with tweezers and
pull it off.
pull the rest of it
Nice.
off. So that was two little resistors that we removed.
Yeah.
And that's kind of all you need for the resistors. And then because the SD card ends up sitting on top of the board, I take the reset button and I just flip it back and forth a little bit.
Off it goes.
And off it goes. So that's the reset button that's been removed. So now the components that need to be altered are off this board. Now in high power versions, when I'm actually trying to get long life, I take the voltage regulator off as well. That's this guy, and I'll solder a new voltage regulator in place on these pins directly.
Okay.
But it's not needed. You can use the voltage regulator that's on there. It's only about half as efficient at low power. So if you want to double the lifespan of your logger, you change the voltage regulator. But you still get as many months of operation with the default. So that's fine. Now we're going to add some wires to the I2C interface. That's pins A4 and A5.
Perfect. I can see them now.
Okay. So first we'll get our wires cleaned. Alright, so I just pre-tin these little guys with a little bit of solder so that the wires are stripped and tinned before I try and connect them to the Arduino.
With a little bit, so you put the flux and the solder and then...
Yeah, and I use just a pin.
Yeah.
Like this is just a tiny bit of flux, and you want the solder to not be globbed on there because it still has to go through the board, so you just want a tiny little bit of... You should be able to visually see. Yeah, it becomes shiny when it's covered. So that one's ready.
Perfect.
And then I'll get the white wire and do the same.
Love the fumes.
You get used to it. Okay. So there's the white wire. This is going to be the data wire. I always use yellow for clock lines on digital sensor buses, and I use white just out of habit on data lines. Okay, so I put too much solder on that, so I had to take some away. Okay. Now it's nice and thin and shiny. Okay, and these wires are going to end up going through the top of the board. So the white will go on A4. Now to do this, I need to hold the board in place with the pan of ice and some helping hands. So I'm just going to pull this out.
We'll have to see how we're going to do that. So
let's pull this out here. Okay, so now it's in the vise.
Yeah, it's in.
And we need another little helper here to hold the wire in place. So this is going to disappear off the screen for a minute, but I have to.
Okay.
There's the A5. Okay, and then I bring in the helper. And the helper clip holds the wire from below.
Perfect. Nice. I can still see you. You're yellow. So very good.
And then you can
use flux because you already put the solder.
There's already solder on the wire, and there's some flux inside the wire.
That you already put before.
Okay. And I just hold it with my fingers to make sure it's straight and wait for it to cool. And we get our little Hershey's Kiss of solder. And we can trim that off. So that's the A5 connection. And then we bring in, we do exactly the same thing over again.
For the A4.
For A4.
Okay.
It's a little tricky.
Yeah. There, I can see it.
Okay, so there's A4.
There, perfect.
Okay.
Yeah.
And again, we bring in the little helper to hold on to it.
That's the yellow guy. So.
Okay, so that it's being held
Oh,
from
the white
below
one. Okay,
with the
perfect.
helper.
Uh-huh.
Let me solder that wire. And we wait until the flux burns off. Sometimes I'll hold the wire from below just to make sure the position's good. And then it cools. You can blow on it sometimes to speed that up. No, I'm serious. Sometimes you need to prevent your fingers from getting burned.
Yeah, yeah.
So now we have nice clean little join there.
Okay.
And
okay.
On A4 and A5.
Perfect. Can you go ahead and turn it around so that you can see how the kisses are in the other side? Just
oh,
the opposite side.
I've trimmed them so
no,
that
that's
they're
perfect.
not.
You can still see the kisses. No,
okay.
That's perfect. Okay.
All right.
Yeah, good.
So now we're going to pin the rest of the board, and that's a little bit trickier because we need to alter the arrangement of the pins.
Do you want to show that guy?
Yeah. No, that's going to be in
okay.
In the video. We may have to pull back a little bit.
Yeah. Do you want to do that then?
Actually,
no. Let's just leave it like that.
Good.
That's good.
Or if I work this way.
Yeah.
I
Either
think
way.
that's better.
Perfect. Yeah. Okay. I like this zoom level. The other one, I was guessing what you were telling me.
Okay.
Actually, now I can see.
Now you can see what we're doing. All right. So
I'm happier
because I don't use the reset pins on my loggers, we're going to skip. There's a reset pin right there. We're not going to put a pin there, and there's another one on the other side, a reset pin here. And underneath the screw terminal board, we're going to change this terminal into VCC. This is the positive voltage. It's always useful to have more VCC and more ground lines. And so reset lines are not as useful to a data logger in general. So we're not going to pin the resets, and under the board we're going to turn those into more grounds and more power supply lines. And that's just been very useful over the years. Deciding to not bother with the reset lines and get more grounds. You can never have enough grounds and positive power lines on a logger. You always end up needing more. So okay.
And you measure the size of this guy. That way you know that it's the right size. Okay, cool.
Yeah, you can always just sort of count your pins and clip these long pin header rows. So I know that I've got 3 that I'm not using. But on this one, I'm actually going to extend past by 3. So I want.
Have these 2, 1, 2, 3.
1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to cut this for the 9 plus 3 more. So I'm going to cut this one to 12. So actually, I think that's the standard length it comes in. So 3, 6, 9, 12. Okay, and that's going to extend past the board, but there's a good reason for that. We're actually going to
so you skip one because
I'm skipping the reset. Yeah.
Does it matter like how far are you from the groove in the middle, or can you go the other way a little bit?
No, you can go either way.
Okay.
This is
so it doesn't have to be symmetrical or whatever. It doesn't matter.
Well, it has to line up. What we're going to do is set this on the pins when we're soldering the pins.
But with respect to this horizontal groove, that's the groove on the breadboard. No, it doesn't matter.
Doesn't matter. We're just trying to get it to align with our little Arduino board. Okay. So the next one has to be 9 pins. Well, let me check here. We're skipping the first 3. So 1, 2, and 3, and I need the rest. So if I just count the pins on the Arduino board.
There you go.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 pins on the side. We've already got 3. So the gap plus 1, 2. So we need the remaining row to be 9 pins long. 9 pins long to finish that row. Okay. So what we're doing is just getting enough pins in the board that there's 3 extra down here, because these are going to take at the end of the board. This end here. There's ground A6 and A7.
I can. Oh yeah. Okay. You're pointing over in the bottom. Okay, there you go.
Ground A6 and A7, and these extra pins that stick out are going to be attached. So we basically now line up our.
I think you can even see it at this zoom level.
Okay, and I actually end up with 1 extra. That's 1 more than I need, but I'm just going to leave
Move
that.
it to your right a little bit. There. Okay, so we can see the. So we have an extra 4, yeah. So
yeah, there's 4. I only meant to put 3 on there.
Yeah.
So I can actually just go in and trim that if I want.
Yeah. Okay.
And take it off. Because we only needed 3 extras.
Yeah.
There we are.
So
okay. That's what we actually wanted there.
Okay, perfect.
Okay.
Super.
So now I'm going to start soldering those pins, and I always do opposite diagonal corners just to hold it in place. So I'll start with this guy.
With the raw.
Okay. And I'll get him pinned, and basically you have to heat up the pin first and then bring the solder in, and it has to flow down into the board and around the pin. So I'll just let that go. It's bubbling a little bit.
Yeah.
But the smoke is gone. When the smoke is gone, you've burned off the flux.
Okay.
We're gonna clean these boards afterwards, right? So here's my diagonal corner.
Okay, that's the next one over.
That's the next.
You
And I flipped it around. Yeah. And I'm just sort of holding it in place. Wait for the flux to burn off. Don't wait too long because you don't want to cook anything.
Yeah.
So now this pin
is good,
and this pin are done, and it holds it all in place, and I can just continue and do the rest of the pins. Perfect. So I'm just going to do that now.
Perfect.
And I'm using 0.5 to 0.6 solder. So the size I'm using is 0.6. Okay. 0.5 to 0.6 works well for doing this job. And I'm running the iron at 700, which is a bit hot.
Yeah.
I don't usually run that hot, but for pinning, because there's so much metal and it pulls the heat into the sacrificial breadboard, this breadboard will not be useful for anything else after this point, because we're cooking all the little electric contact points in the breadboard. Poor breadboard. So I always have a sacrificial breadboard for doing pinning like this. And you can see if that's bubbling. Yeah, it's I can see the fumes. Yeah, that's excess flux. We can't burn all the flux off because then the other components on the board would get cooked. But I usually take a bit off, and then we'll do an ultrasonic cleaning on this after it's been done. And the ultrasonic cleaning will take all of the flux that I'm adding with these pins. How does Trish does in her classroom with the fumes? Like, it's okay if you do 1 person, but if you have like 8 persons doing the classroom's quite large, so it diffuses. And there's also a fume hood in the room, so if you open the fume hood at the front of the room, it just pulls air through the whole place. So probably a lab would be better to do this, so we have the fume hood too. That's always the case. Yeah. There's tons of things about assembling data loggers, like especially the PVC gluing. The PVC gluing is nasty, nasty fumes. And so you want to do that in a fume hood for sure. Okay. And it's kind of, this is a timing thing. Like you can see how long I'm holding it. That's something you only learn by doing it, right? Yeah. And so after you've done a few of these, you start to just get a feel for, does that joint look like it's done? Yeah, it has little keys. And you see it, the solder flows into the hole. Okay. And you don't want to hold it too long, and you don't want to hold it too short. You just kind of, you just practice it. Yeah. Yeah, it's good that you start doing this with relatively like farther away.
have still hands.
Yeah, I rest my hands on things. I have little wooden blocks, actually.
Oh, that's a good wood block that you have there. Nice, that's smart, actually.
You'll see on the other bench, there's a whole bunch of little supports, because my nerves are getting shaky. I'm getting old, and so I need little supports for my hands.
Oh, yeah. Yeah, I know. I have a friend who smoked that. We're trying to weight like 0.05 milligrams or something, and it's like, oh, okay, good luck.
Good luck, yeah.
Yeah.
Okay.
Oh yeah, that was very nice. Super nice case there.
Yeah. Well, like I said, it just takes a bit of practice, and you will get a sense of it. And one of the things that makes them look good is if you lift it up straight after you've got the solder on the pin, you get a nice even cone.
Oh, really? Okay.
Yep. Once the pin is heated up, you can push the solder into the base of the pin rather than on the iron.
Say that again?
I'm pushing the solder actually into the pin.
Okay.
So I'm not melting the solder
With
on
the
iron.
Got you.
If the pin's hot enough,
then you don't need to touch the iron.
you don't need to touch the iron.
And that's probably better. That way you don't over.
So these last three, we're going to jumper across from ground A6 and A7 to these extra pins. I have to give credit to Brian Davis for coming up with this. He actually has been building some of these loggers, and he pointed out that it was easier than running the wires under the board to just do this and get them connected. So just credit where it's due. This was Brian Davis's idea that I'm stealing.
Well, now you're sharing. Okay. So you're putting now the flux.
I'm just putting enough flux on these pins so that we can solder them and tin them so they're ready before we bring the wire in.
Yeah.
Okay, so those three pins now are coated with solder, which is good. And I generally just use a scrap resistor I have lying around for the wires. These are a little thin, actually. I should probably get some nice thick wires.
You think so?
Well, these are the metal film resistors, and they're kind of crappy. They have very thin wires on them. I have some old carbon resistors kicking around, and they have thicker wires. I think I'm gonna grab some of those. Give me a moment here. Okay, so we're gonna be jumpering these three connectors at the back of the board to these three pins that we just tinned. And so the first step is to make sure that the wire that I'm using is coated with flux first.
Yeah.
Okay. Perfect. So this is a little bit too crunchy. It needs to be smooth. I didn't quite get that coated well. It's an old wire. It might not have taken.
It looks better now.
Okay, that's a bit cleaner. It's got the solder on it and it's clean.
Yeah.
So I'm just gonna clean my iron a bit. All right, and so now the idea is that we're gonna put this in here. That's actually too thick at the end, so we have to clip some off. Okay, so now it's nice and clean. I'll just put that in. And the first job is to just solder it into the hole, and then we'll bend the wire over and connect it to the pin. Okay, we just let that cool. And this is a little tricky. I don't know if I'll be able to keep this in focus while I'm doing this, but I'm gonna...
I think you're good, yeah.
Okay. Just bend this over, and then I usually sort of twist it back up so that it's parallel.
Move it a little bit.
Okay. Oops.
There.
Oops. See, it's a little hard to get the positioning right. But anyway, so it's now... The wire's been bent to try and get it into contact. And then we will solder. The pin already has solder. The wire is already soldered. This is really just a case of joining the two up, which is mostly about just melting it thoroughly. There we are. So everything's now liquid.
Okay.
Okay, and I wait for it to cool. Then we cut the excess. The excess wire gets cut.
There.
So now we've joined A7
with
to
the
this
first
pin.
Yeah.
And we're going to do the same with A6 to that pin
Okay.
and ground to that pin. Okay. Prepare another wire. Doesn't have to be a resistor, it's just this is the wire I have handy.
Okay, cool.
Okay, so that's now coated.
Okay, good. There you're centered.
Okay. Just
More or less.
okay. So that's cool. Okay, so again, we're just putting it in position, and the trick is to not, you know, accidentally solder it to the other,
the wrong pin, yeah.
to the wrong pin.
Okay.
I don't know if that's visible or not.
That's visible, I think that's fine. Yeah.
Okay.
I think the fact that you showed that how it looked vertical before, that will help people to have an idea of how you have to do it. So. Okay, nice. This looks very nice. Yeah.
Okay, and now I just have to trim it off. Trim off the excess.
Perfect. Nice. You're still there?
All right, now we do the next one. And we could, in fact, do the other wires that way too. Some boards have other pins at the back. This is only one variant. There's lots of little variants of these Arduinos. And so your particular Arduino that you buy, if it's a Pro Mini clone like these are, there's flavors of them. They have all sorts of extra pins and things. And some of them have the SPI bus broken out at the back. And some have all sorts of extra stuff. So this is a variable area on the different types of Arduino boards that you might end up seeing.
Yeah, depending on what you need it.
Depends on which board you're using. This is just the flavor I use. Because we break out the I2C bus through the RTC, basically, I don't need those other extra pins in this position. But if I had a different use, I might.
Yeah. What is the I2C, by the way?
A lot of sensors communicate with digital protocols. You're not reading an analog voltage off of them. You're actually doing handshakes, saying, "Hey, sensor at address 1, what have you got for me? And sensor at address 1 goes, I've got some data. Are you ready? And then the Arduino says, yes, send me 1 byte of data. So there's a whole handshaking process. And that handshaking process is called a protocol.
Okay.
And so you end up with sensors that speak these protocols. And I2C is my absolute favorite for these loggers because it's built into the Arduino chip. It's not something you have to do in software. You don't have to program the Arduino to know how to speak I2C. It knows automatically because it's already built in.
It's it's language.
It's a
language kind
It's a language built into the Arduino.
Yeah. You're in. You're good.
And so it's fast and easy, relatively speaking, and the RTC speaks I2C. Okay, so we already have a device on the logger which uses that protocol. So if you add another one, bus protocols, the whole point of a bus is you can hook as many sensors as you want to those same wires, and they all get along as long as they don't have the same phone number.
Yeah, right? So they all keep their space,
They all keep their space.
Yeah, nice job. Yeah.
So that's the 3 pins connected through.
Yeah.
Okay, and then the last thing is to put the UART connector on.
The UART connector.
That's this guy at the end. So I'm using the corner of the breadboard just to hold it while I tack the corners. So again, I do a pin at one side. I have to let it heat up a bit. And I hold it in place and let that just bond. Okay. And I'll do the other corner.
Okay. So again, start with the corners, fix it, and then you just fill in.
And then you fill in the ones between. And that just prevents you from accidentally putting them all in at an angle, because if you start at one end and work all the way through, it's easy to get them bent or something strange happen. Okay, and I actually did a little touch down there. Alright, so that is the main board, basically completed. So there's 2 reset pins that we're not bringing down to the screw terminal shield. Okay, and we have the I2C bus is broken out on these wires, this A4 and A5, and that's going to go to the RTC.
Daytime power.
Yeah, we removed the reset switch, and we've extended those with 3 pins extending farther than the length of the board to take A6, A7, and ground. Okay?
Yeah, perfect.
So that is basically component 1, paired and ready.
Yeah, super.
Okay?
Nice.
So this is isopropyl alcohol. Put a little bit on a Q-tip.
Okay.
So it takes a bit more time to do this, obviously, but it's still
worth it,
it's definitely worth it to get as much of the flux off of your boards as possible. These days I actually soak them in a bath of isopropyl, and I have a cleaner.
Do you clean the back too as well, or just the top?
Yep. No, you clean every surface that you soldered.
Okay.
You need to try and get all the flux off. Doesn't matter what you did.
Okay.
Okay. So I'm gonna clean
Yeah,
that, and I'm actually gonna cut. Those need to be trimmed down. I forgot to trim
those guys. Yeah.
Those little ends, so I'm gonna trim that as well.
Okay, just go ahead and do that. Okay.
Okay, and then we clean. And when you've cleaned it like this, you have to let it sit for a little while until it's completely evaporated and dried.
Okay.
But I do as good a job as I can to get rid of all of the flux that I've left on a board.
It doesn't matter about the pins, or I guess, yeah, the pins that you solder on the...
Every pin you solder needs to be cleaned.
Yeah, even the 3 ones that are all the way in the stream.
Yeah, everything that you can clean, you should clean.
Okay.
Okay, so just to make the tape more flush with the surface and make everything flat, I usually trim these pins, but that's totally optional. It just makes it easier to put the mounting tape on.
Why do you think it will be tricky with the students?
Well, it's easy to cut too far down and cut into the board by accident.
Yeah.
So I'm not sure.
That'll be a waste, yeah. That'll be more advanced, like if you have to do it again for someone else or something.
This is a step I do with my loggers.
Yeah.
Okay? But I'm not sure a beginner would necessarily want to...
Oh, so even for those guys, okay.
Yeah, again, because you want them all to be under the
Yeah.
SD board. So I've just trimmed away excess.
Okay.
So that just gets us with smooth surface. And I missed one here. I'm going to take that.
Yeah, there's one.
Okay.
And what about the other bumpy ones on the other side, like close to ground?
We're not going to do here because I only put tape on this surface,
Okay.
right? This is the
perfect.
surface that gets taped. But before we do the taping, we have to coat this with silicon conformal coating.
Oh, okay. So let's just go ahead and show that thing. Okay.
That's this stuff.
There, perfect.
Okay.
Yeah.
So this stuff is about 12 or 15 bucks from Amazon for 55 mils. It's kind of like nail polish, but it's a better vapor barrier, and it's soft. It smells pretty bad, but the idea is once you've got a board clean, you coat the surfaces, and it always seals itself shut.
Good.
Okay.
You know, that'll be a struggle to open.
And it definitely, this is a fume hood thing. All of the things that we soldered get this conformal coating put on them. You don't want to put it on the pins, obviously, because then you wouldn't be able to make any electrical contact with them. So then I go through and I cover the whole...
Oh, the whole thing.
The whole thing. And this is what seals the moisture out so that your data logger will last a long time.
Okay.
Okay. And I can go around. So all the pins that we soldered get coated like this.
Yeah.
Let's give these little bits underneath the coating. And again, if you were working, quickly, you could skip the conformal coating stage, but I don't. I like having my stuff with a nice...
So you can rely on it.
I can rely on it. Yeah. These things have run for years in the wild with this coating. So
how viscous this thing is? It's pretty liquid.
It's pretty liquid.
Yeah, okay.
So it will, if you're not careful, it'll run into...
Okay.